We are starting on page 225. This is Module 2, Topic 2, Lesson 1, titled US Shirts, using tables, graphs, and equations. So our learning goals: construct a table of X and Y values and a graph to model a linear relationship between two quantities. Use different representations to model a problem situation. Analyze the characteristics of different linear relationships, and compare linear relationships using three things: tables, graphs, and equations. Our warm-up or our review today is solving an equation, so we have some experience with this. We're going to forego examples 1, 2, and 3. Let's just do example 4, and then we'll move on with the rest of the lesson. Right, so here we're going to be doing two things here. First thing is we're going to undo subtracting 3, so we're going to add 3 to both sides. All right, this equals 0, and we're left with 2x equal to 5 plus 3 is 8. And at this step, you're trying to figure out, right, 2 times what is equal to 8. You can figure that out, but if you're not sure, that's why we go through inverse operations. This is 2 times x. So what's the inverse is, instead of multiplying by 2, it's dividing by 2. 2 divided by 2 is 1. And then we have x equal to 8 divided by 2 is 4. So we'll go through that way. All right, so just a little bit of a review on solving equations. Let's go to page 226. Total cost, and that's figured out by using $8 per shirt plus a one-time charge of $15 to set up the design. So let's say you want, so number 1, describe the problem situation and your responsibility in your own words. Okay, so we're going to say that the total cost is determined by a couple of things. We're going to say the first thing is quantity, so the number of shirts, and we'll just put in parentheses, this is $8. And 2, this is a setup fee, and I'll put in parentheses, that is $15. Okay, so the setup fee is a one-time fee, but every single time we purchase a shirt, it's $8. Number 2, is the relationship between the number of shirts ordered and the total cost of an order proportional or non-proportional? Now, the way you can determine that is proportional means that it goes through the origin, so it's 0, 0. What this means is if you purchase 0 shirts, you would pay $0. Now, that's actually not the case for this, because this is, I'll actually circle it, this is non-proportional. It is possible for you to actually pay money without even purchasing any shirts, because you'll have to pay the, I will say, $15 setup fee to initiate, so to start an order, including shirts. Okay, so 0 shirts, but I'm still paying $15 for them even to design the shirt, to design whatever logo or design that you want this place to make. Okay, if it were $0 and 0 shirts, then it would be proportional, but this is non-proportional. All right, we're going to be working on activity 1 and 2. As we go through this, you are allowed to use your calculator. I would say use the calculator that's embedded in your Chromebook, because there's quite a few calculations that we're going to be doing. Okay. Let's look at it. Activity 1, so modeling a linear relationship. It says, let's analyze various customer orders with US shirts. So number 1, what is the total customer cost for each order of shirts? So we'll set it up and then we'll calculate it. For 3 shirts, right? So we have the design, we paid the initial fee, we're paying $8 per shirt. In this case, it's 3 shirts. So let's go and write this out. This will be $15 plus, if it's $3 per shirt, the way we'll write that, it'll be 8 times, I'll put parentheses to represent times. Oh, oops, I should change the dollar sign. So $8 per shirt times 3. Okay, now this we will use order of operations. So we're going to first multiply and then add. I'll get rid of the dollar symbol here, at least to calculate. So 15 plus 8 times 3 is 24. Now the total cost, we're going to add 15 and 24, and that is, final answer here is 39. Okay, I'm going to work out the second one, and I'll have you do the last one as you do. on number 1C. So if they want 10 shirts, so it's going to be 15 plus $8 per shirt, and we're going to order 10 shirts. Okay, so this is going to be 15 plus 8 times 10 is 80. And what is 15 plus 80? Right, it's 95, but this is total cost $95. Okay, and then the last one is a UDO, so go and try to figure that one out. You don't have to write UDO, just pause the video here and try to figure it out. So let's go to D, explain how you calculated each cost. Is we first multiplied the amounts of shirts by 8. Then, right, we added the setup fee. We added $15 for the setup fee. It's a one-time fee, so that's not something that we are multiplying by just adding. Number 2. So number 2, same process here. How many shirts can a customer buy for each amount? So let's say, right, you have a certain amount that you can purchase shirts from. We want to figure out what's the most amount of shirts we can purchase with this amount of money. So this definitely use a calculator here. I'll be writing the answer, but we're gonna have to work our way backwards. So how many shirts? So if we have $15, working backwards from there, or sorry, $50, working backwards from there, I'm gonna have to subtract the initial fee. Right, we're always paying $15. So let's put minus 15. Now whatever is remaining from that, from there, since it's $8 per shirt, you have to figure out how many groups of 8 can you purchase. How we determine that is we're going to divide whatever that remaining value is by 8. Okay, now this, we're definitely going to get a decimal. We'll round to the nearest penny. So 50 minus 15, what is that? That's 35. Okay, so you can plug this into your calculator, put 35 minus 8, but that'll give us something close to 4. This is 4.375. Okay, now this would be right. This would be 4 shirts, but you can't purchase 375 thousandths of a shirt. So this, our final answer, we're actually going to ignore the decimal part. You actually can't round up; you have to round down. But for this, it is 4 shirts. Okay, we're going to go through the same process for $60. Right, it's the same thing. Instead of 50, I'll put 60. It's 60 minus 15. Divided by 8. So 60 minus 15, that's 45. 45 divided by 8, that's not a nice number, but that is 5.625. Again, ignoring this remainder, this tells us that we can only purchase 5 shirts. Okay, and I'll leave this last one, 220 as a UDO. Yeah, it's a bigger number, but you do have a calculator, so you can figure that out. It's going to be a double-digit number. So D, same exact process. How do we calculate this? This is we first had to subtract $15 from the amount we started with, from, we'll just say starting amount. All right. And then the remaining value, so we'll say the remaining value was divided by 8, since it's $8 per shirt. Okay, and then we had to ignore any remainder, right? Because you cannot purchase a partial shirt. All right, and then number 3, identify the variable quantities and constant quantities in the problem situation. So what are the things that vary? What are the things that are constant? Meaning, what are the things that stay the same? Let's say variable quantities. I'm just going to draw an arrow here. The thing that's variable here is the number of shirts. Okay. The things that are constant, actually, variable shirts or number of shirts, and also, actually, we'll just leave it like that. I'll just put one thing. The constant is the setup fee. The setup fee is always the same. It's always going to be $15. Number 4, identify the independent and dependent variables. So there's some things that vary here. The independent variable, I'll put IND. Right, this is number of shirts that you purchase. That's the independent, nothing really affects that. The dependent variable, the thing that is affected by the number of shirts that you want, is the total cost. Right, so total cost depends on the number of shirts you decide to buy, or the number of shirts you decide to buy affects the total cost. Okay, let's go to the remaining part of activity 1 on page 228. All right, now we talked about in the learning goals is that we are going to represent using varying things, tables and graphs, so that's what we have this. But let's go through activity 1, number of shirts. I'm actually just going to give you some varying numbers for number of shirts, and I'll have you determine what is the total cost. Okay, so we're gonna start out with 3, we'll go 4, 10, 25, we're gonna increase it by quite a bit. We'll go to 100, 120, and 150. Now we just did this for a lot of what we just worked on, is you take the number of shirts, and what you do is you're going to, right, you add 15, you multiply 8 times whatever the number of shirts is. I'll represent that using X. So 3, we did that earlier for the first problem, right? 3 times 8 is 24. 24 plus 15, that's 39. Okay, now that, I'm actually also going to do number 6 at the same time. Let's graph that. This gives us an ordered pair. That ordered pair is 3, 39. So if I go over here, number of shirts is 3, and the height is 39. So 3, this right here is about 2.5 since it's half of 5, so 3 is a little bit to the right of that. This right here is a height of 25 since that's half of 50, so 39 we're going to say is somewhere right here. So this is 339. Okay. All right, let's go to the next one. The next one we also did, actually no, we didn't do that. Oh no, we did. 4, this is, actually no, we worked backwards. This was 4, if you multiply this by 8 and add 15, it's 47, so let's do that one. This one is close to 5, 47, somewhere right here. Okay, so that, and it doesn't help us too much, but it gives us a general idea of what's happening with the graph. All right, let's go to 10. This one we did do on number 1B, right? So 10 shirts, we multiplied it by 8, which is 80. 80 plus 15 is 95. Let's graph this one, 10, 95. So 10 to the right, 95 up. It's close to 100, but not exactly 100. Something like that. Okay. I'm going to skip to 100. The 100 is you're supposed to have done this for the UDO for number 1C. This would be 815. All right, so 10, 800, or 100, and 815. That's off the graph here. The furthest right we can go is past 30. You know what, let's go back to 25. This is 215. So 25, 215, that is 25, 215. Somewhere right here. All right, now as best you can, we see a lot of points here, and I think a lot of these points represent. It looks like it's proportional. It's not quite exactly proportional. We'll talk about this soon, why it's not. Right, this looks like it's close to going through the origin, but it's actually not quite. There's a reason for that. But anyways, we get a line here. It goes through the varying points, close enough. Just do the best you can to draw a straight line here. All right, and C, define the variables and write an algebraic equation for the situation. All right, so the variables that we have, I'm going to put C. We're going to have C as total cost. Now this is our dependent variable. Dependent variable is always Y, but we can see that here. I'll just put C right there. And number of shirts, X right here. I'll put that this is S. Number of shirts. All right, that tells you that this is independent. We'll put S, and this is dependent. The equation that you have here it should be C equal to, the total cost is 8S, 8 times the number of shirts plus 15. Okay, we're going to be using this equation, 8S plus 15. We actually have been using it, but we haven't written it down. This should help us for the other problems that we go through, but let's go to activity 2 and finish that one up. Okay, activity 2, modeling another linear relationship. So What we have here is a similar context, but we have a different store. So it says one of U.S. Shirts competitors. It's called, so instead of U.S. Shirts, it's called Hot Shirts. Advertises that it makes custom shirts for $5.50 each, with a one-time setup fee of $49.95. So close to $50. Your boss brings you the advertisement from Hot Shirts and asks you to figure out how the competition might affect business. It's going to hurt our business. So any one of that. So here, let's highlight. We have, right, it makes t-shirts for $5.50 each, and we have a one-time setup fee of close to $50, $49.95. Okay, we're gonna go through the same exercise here because what we're gonna do is we're gonna compare these different quantities. Let's go through number one. What is the total customer cost for each order of shirts from Hot Shirts? So let's go through number 1A, which is 3 shirts. So what we started with on the other one was $15 for initial fee. This is a lot more, right? But in this case, we're not multiplying by 8. It is $5.50. So this is, we'll just put 5.5. 5.5, the same thing as $5.50. And this one, we're going to multiply it by 3. This one, I'll actually just give you the answer. This one is $66.45. So that, we do get a decimal here. And that seems like a lot, right? $3 for, or sorry, 3 shirts for $66 roughly. That's quite a bit. Okay. We're not going to go through D, but let's go through B and C. This next one, $49.95 times 5.5, or plus 5.5 times 10 shirts now. Multiplying by 10, this is just 55. 55 plus $49.95 is going to be over $100. It's $104.95. Okay, and 50. How do we write that? All right, we're going to put $49.95 plus 5.5, and we're now multiplying with 50. You're welcome to put this into your calculator, but this is quite a bit of money to purchase 50 shirts. Obviously, it's going to be a lot. $324.95. Okay. All right. Now from here, number 2, we're going the other way around. Now we're trying to determine number of shirts. We're just going to do this for A and B. We'll cross it off for C. How many shirts can a customer